Water Action Volunteers Program. And I guess I didn't properly introduce her before because I'm going to do it right now. So she has come, she spent a long week data crunching so that she can share a lot of this with you today. And why is it not?
It's because I shut it off.
Oh.
Well, it
Okay.
Is it doing it now?
Yes.
Yes,
You've
it's
got
good.
it.
Yeah.
I was going to say we tested
My
it
bad.
before
Yeah.
it worked. So with that said, I'm going to turn it over to Chris to tell you all the wonderful things that you guys learned this past year and beyond.
Oh, and I'll echo Jane's words. Thank you for collecting all the data. You overwhelmed us with data, and I'll work my way through what I was able to analyze. And as I said to Jane, I wish I had 200 more hours this week to continue to analyze the data, because as I got into it, it made me have more questions and I wanted to analyze it in other ways. And so some of the ways that I've analyzed it that I'll present to you are a little bit, you deserve a little better than what I'm going to give you. But other things present some interesting questions. So my goal is that I can continue to dive into the data. The program has been around since 1996 in the fall. I came on board in 2001, so just before, the earliest data that I found from Waukesha County was from 2000, and it looked like about 1 or 2 data points, not too many. And then 2002, so you all were saying, who's the 2002? Who's been there?
Richard.
Richard.
Oh, he left.
He left, oh, okay. So one of the things I have in my hand here, for the program, we have, as you know, we have the 3 levels of the program, the entry level introductory monitoring, level 2, and then level 3 special projects. So for level 2 and level 3, we have the ability right now to create site-specific reports after each season. And one of the cool things that's going to happen with the database change is that we will be able to create site-specific reports for everybody come this summer. Really, we'll do them in the winter. Once that happens, just to check, did anybody new come in public-wise, or is everybody is wave people?
We're all
Everybody's
wave.
yeah. Okay, so what I did in terms of reports, I printed out 3 of each for the specific sites. So if you want, I will hand around reports. If it's your site, take one, and if it's not, make sure the person whose site it is gets it first, and then there'll be 2 extras. So I have phosphorus reports for Cocoa Creek. It's at County JJ, so it's not specific to Cocoa Creek.
It's Nancy and Sue.
You guys. I have Mason Creek at Peterson phosphorus.
That's Rebecca.
But I'm sure they won't.
Okay. Oops. Okay. And then I have level 2 reports. I have Battle Creek at BB.
That's Richard who left.
Richard left. Okay, so have at it. Anyone who wants Battle Creek at BB. Anybody want it? Okay. I've got Oconomowoc at West Shore Drive. I have Bark River at Genesee Lake Road. SVT. Okay. This might be to Pewaukee River at Capitol. Yeah. Okay. They were in order of person. That's what I know. I have Springbrook at Holiday.
It's Tom, yeah.
I have Genesee at Old Village. That's Tom's, go back. And I have Bark River County P Square Road.
Here, got it.
Yeah, okay, I've got a different one. So this is the level 2, that's the phosphorus.
Okay.
And then Mason Creek at Peterson.
Oh, wait. Yeah, that's Rebecca.
All right. And apologies if I don't have one for specific. Okay, so what I wanted to do to talk about your data results was to compare your data results to what we know statewide. So this map is showing last year, 2014, a record year for Water Action Volunteers. We had 655 sites monitored statewide in the 3 levels of the program. So there's level 1 is the blue circles, level 2 is the yellow, and then we had 2 different level 3 projects. We had a road salt project that Jane did, and then we had total phosphorus monitoring also that Jane and some folks did. So you all know the goals of the program. This was written just in case there were public folks who came in, but our goal is that we can have all of you understanding what's happening in your local waters, and that you feel confident that you understand what's going on that you can then try to do something to be able to protect those waters or to improve them for the future. So the sites over time, statewide, back in 1996, we had 4 sites in the fall of 1996, and we've seen this huge growth over time. There's a couple of jumping spots here in 2006, we jumped up, and again in 2012. And what happened in those 2 years, 2006 is when we added our level 2 program, 2012 is when we added our phosphorus monitoring. So you can see when people were getting on board and doing those other options. For you guys, Waukesha County, the earliest data, again, that I found one data point in 2000, and then I found 2002 and on, and you're seeing a similar increase over time with 42 sites monitored in 2014. If you prefer to look at it this way, you can see where you all lie. I didn't label them because there are too many to be able to read it, but what I can tell you is that there's 22 different streams in 9 different watersheds. So, let's see if we can do it. Anybody, we don't, the Asheton River, we have a Conowalk here, right? So we have Conowalk, we've got, what do we got? Okwanago, Middle Forks Fox, Upper Fox, there's the Menominee over that way. I swore I would remember what that is, but I don't remember what it is. Help me out.
Battle Creek,
Battle
yeah,
Creek.
Bark River.
Thank you. I was like, oh, I don't need to have the name on there, I'll remember. So you are well spread out over the county. And you all know what's monitored. Again, in case the public had come, here's what you all monitor. You know that the 6 things in level 1, the flow, the habitat, water clarity, temperature, macroinvertebrates, and dissolved oxygen. If you are not familiar with what folks do in level 2, if you are a level 1 person, the difference has in the past been level 2 folks will get a dissolved oxygen meter, a pH meter, and they get this little device called a tidbit, which is really only about this big, and it collects temperature every hour from the time we tell it to till the time we tell it not to. And then transparency is the same as level 1, and then the level 3 projects for the bottom 2, the phosphorus is that bottom middle. Here's the vial. Who asked about how much acid? Here's how much acid, little vial of acid getting added to the sample, and then conductivity is being monitored in the lower right. If anybody is interested, Lindsay Albright is our new level 2 coordinator, and she said she has 5 level 2 kits that are actually the meters. So if you're interested in moving to level 2 and you wanted to get in on a meter before we stop buying them, let Lindsay Albright know, and she will come out and teach you how to use it and set you up with the equipment. Okay, so what do we have for data? We have over 13,000 field visits that people have made in the last 17, 18 years with WAVE, plus thousands of level 2 site visits. And the reason I don't have an actual number for level 2 is because of those continuous temperature monitoring devices. Just for the level 2 sites sitting in this room, there was over 70,000 observations because it's every hour. So it overwhelms the computer when we try to say how many observations have been made in level 2. So thousands and thousands and thousands of observations. Within this county, you've made over 2,500 observations, site field visits, to look at the water's health. So thank you. Okay, so transparency. Things I think you know, but just in case you don't, we'll go through it. So every stream has a baseline transparency. And like Jane was talking about, there's certain streams that she knows are the problem children. However, since each stream has kind of what is expected in that stream, then the life that lives in that stream is expecting the clarity to be what it is. And probably it means that there's probably warmer water temperatures, which probably means that you have a different fish species that are living in a cloudier stream than in a cool trout water stream. But what happens is if you have your transparency that's normal to that stream and it changes for days or weeks or months from what it normally was, then you're going to start to see a shift in what organisms can survive. And that's when there could be a problem. Or if you have, say you have a really cloudy stream and you wanted it to be trout waters, you need to do something to make it not cloudy so that it can be cooler so that the trout can live there and spawn appropriately. So we're looking for changes, either desired changes that you would like to see by management or changes that happened due to land use and changed what you were seeing over time for the transparency. So the turbidity is the cloudiness of the water. So site feeders, it can affect the water temperature, it can affect plant growth. If the plants need the sunlight to respire or photosynthesize, then if they can't get the sun, they're going to be affected. And you all know, bottom left picture is going to change. So you all know how to use a transparency tube. If it's cloudy, you can't see the black and white disc. If it's clear, you can. Same thing, since you all have done this before, you know this is your transparency tube. If you can only fill it up a little bit, you know the water clarity is poor. And on the other side, if you can fill it up a lot, you know the water clarity is good. And hopefully you've all seen this chart in your methods packets. What it is we're looking at the water turbidity here and then time. And what somebody did is looked at a number of different scientific studies and kind of put them together in one chart. So
Chris,
they say,
that isn't what they did there. I checked into that. I did the literature research on that, and that's based completely on a model. We tried to apply that in the Root River watershed restoration plan, and at best, those axes should be taken as illustrative because there's no data to support that particular chart.
Let me explain what the way that I explain that it means. If you have low transparency or high transparency, low NTUs, this is clear water. At days or hours or days, fish are going to start to show signs of stress. When it's days to weeks to months, then there's other things happening. And I agree, it's illustrative of what's going to happen, but it's written in a box because there are different studies on different kinds of fish that it's going to happen at a different point for different kinds of fish. So they might, one kind, a salmon, might swim away because they can't, they don't like the temperature that's happened when it gets cloudy for a number of days. But another kind of fish might still be fine. Maybe a bass isn't going to leave. So it certainly is not specific to a kind of fish. But eventually, if you end up with months of really cloudy water, then things could die. That's the general point. So here's something, and I did this research, so I know this is out there. This is based on a compilation of research. If you'd like it, I can get you those. These numbers are the NTUs, or the nephelometric turbidity units, which is the conversion between your transparencies in centimeters to the cloudiness of the water. So I know that there's a study that says at 12 NTUs, plant growth is hindered in a certain kind of plant. I know that there's studies that show between 8 and 20 NTUs that brook trout are using more energy to try to find their food. One of the ones I find pretty interesting is 40 to 50 NTUs, little walleye actually survive better because they can hide in the cloudy water. So there's not always a bad thing that's happening when the water gets cloudier. But there's a number of different things that happen as you get cloudier and cloudier water that tend to be things that are not so good for the aquatic organisms. So what do we know about statewide versus Waukesha? I'll do this for each of the parameters that I'm going to talk about, is have the statewide versus Waukesha County. So we've got almost 11,000 observations of transparency statewide, 2,200 for Waukesha County. Both of them, we've got some waters that are really cloudy, some waters that are really clear. So wide range. The average is slightly cloudier for statewide than in Waukesha County. But if you look at, here's our less than 10 NTU, that's biologically, things are happy at less than 10 NTU. I didn't find any studies that showed that there was negative things happening. For the state, it's cut off here, 70% of statewide data say that the water is less than 10 NTU. Almost 3/4, just over 3/4 in Waukesha County show that it is less than 10 NTU. And then we've got lesser and lesser percents as we get to these higher numbers of NTU. So again, the thing about this though is how long and what was the background at your site and how long is it staying elevated. So I don't know how close or how far folks live from your sites, but one of the neatest data sets I've seen is somebody who was working at a nature center and they went out every day and they tracked the rainfall and they tracked the transparency and they could see how long it took to get back to normal. And the question would then be, how long does it change over time? 10 years ago, did it only take 2 days to get back to normal after a 1-inch rain? And now, does it take 7 days to get back to normal? So that's the kind of thing that the more data you have, the more interesting picture you can start to see about a site. if you want to know specifics for each of the parameters, I will also show you the sites of who should be represented in the room so you can see where you lie. They should be hopefully in alphabetical order if I did it right. Here's 10. So 10, anything below here is good. What the yellow bar represents is the mean of your data, and then the top of the blue bar is the maximum you saw, the bottom of the blue bar is the minimum that you saw. So in this case, the sites, and Jane already said it just by having been out there monitoring, we know Cocoa Creek is one of the sites that we're showing something above 10, which could start to be in that plant growth being hindered, or the brook trout if it was a trout stream. We know that the Mason Creek sites are above that 10, and we know far at the end is Zion Creek. Is that, folks who are monitoring there, does that make sense from what you're seeing?
Well, Mason at Northwoods and Mason at Peterson are just a couple blocks apart, and there could not be any problem between Northwoods Drive and Peterson.
The
So that's
difference-
just a timing issue
yeah,
of when
so that's
she's
exactly
doing the
right.
samples and
That's-
I'm doing them.
That's absolutely right. So that's a weakness of the fact that we only can go out when we have time to go out to monitor versus having continuous data over time. So you're absolutely right. We're going to miss things or see a little bit of a different picture depending on when somebody goes out versus when somebody else goes out. So very good. It's a weakness of the fact that I can't say to all of you or Jane, to all of you, you must go out every day, every hour. We want that information. So you're right. We know we recognize it.
Is saying, I'm looking for trouble because we're trying to solve North Lake's problem.
Yeah.
So I would focus after a rainstorm.
Yep, and that's what with the road salt project. That's what we do too. Is we tell people to go out and monitor when we think it's going to be bad water quality, and it's exactly that. We're looking for trouble. We're looking for problem waters. So there is the opportunity, if desired, to bias your sampling or to paint a picture of, hey, it doesn't look good at all, versus, oh, I'm only going to go out on sunny days or when it's been sunny for 2 days prior, which maybe all these sites here that have no range, maybe they only go out when it's been nice for a week because they don't want to get, safety-wise, right? If you don't want to get in a stream that's too deep or too muddy, maybe we're not getting the whole picture. So we have to recognize that that's something that's a possibility. Okay, I'm going to move into my favorite, the biotic index. So you all know it's a water quality rating based on the organisms without backbones that are in the stream. We know that everything that lives requires oxygen, whether it's plants or animal. We know that land use is going to affect our amount of oxygen in the stream based on, for instance, nutrients. If we have personal fertilizing in our yards or on farm fields, phosphorus, one nutrient, sticks to sediments, it runs off into waterways, and that can affect the amount of oxygen. If we bring fertilizers, we grow plants in the stream, we get more oxygen in the afternoon, we get less oxygen at night because there's more things respiring and using oxygen in the night. One of the things we have to recognize, our air, it's about 21% oxygen, so 200,000 parts per million. In the water, it's only 15, and that's on a good day. When you all measure dissolved oxygen, you're usually seeing like 8 milligrams per liter, 10 milligrams per liter, 12 milligrams per liter. That's equal to parts per million. So there's way less oxygen already in the water system, and these organisms are relying on that to survive. So if there's a problem that we cause by our land use that shrinks the amount of oxygen, then we can affect the organisms that are really reliant upon the oxygen, like this stonefly. Anybody get stoneflies at their sites? I didn't look at your organism specific. Jane sometimes gets them. I don't know if you have any there today.
There was one that came out of the stream here
Oh, cool.
in the pan, but I couldn't find it today.
Oh, okay. So they're cool. If you do see them, they do push-ups. They have their gills under their armpits, and if they want to get more oxygen, they do push-ups to move oxygen over their gills. And you can see them literally in our ice cube trays doing that to increase their oxygen.
Can I
They
ask you
care
a
a lot.
question?
Yeah.
Each of these different species, is there data on how much parts per million oxygen that they need?
I don't know about
Yes.
specific parts per million, but in general, so the way that our index works is empirically, this researcher, Hilsenhoff is his last name, he went out and he said, okay, I know there's good water quality at the site from whatever he knew, and so he said, I'm finding stoneflies and I'm finding this specific kind of mayfly, so I'm going to give them a good water quality rating. So we don't from him, we don't necessarily say, oh, we know they need 10 parts per million and they need 20 parts per million. There could be some research studies. I haven't looked into the research to see if there's specific, but what we do know empirically that they need more, like for the stoneflies, there's a water stream over by Devil's Lake State Park. I know I go to the pour over the rock where it lands, where the water lands going over the rock, I can find stoneflies. If I go 6 inches to either side, I'm not finding stoneflies. So I know that they're in the highest oxygenated spot. And so there may be data that says specifically, but I don't, generally what we say is, oh, we just know that they need more oxygen.
Okay.
We had a quirk on North Lake where we lost a bunch of crappies because the water was over oxygenated.
That can happen as well,
And
yeah.
it hit 20, and that was a problem, was windward shore.
Yeah.
In spring after the water.
I'm surprised 20 is high, but it's not, like, Hoover Dam, the fish get the, what do they call it, bulge eye disease?
You'll see it at 140% saturation is
140%.
when, if you get above 140% dissolved oxygen saturation, you'll start to see bulging eyes in fish, and you'll start to see fish kills there.
It was limited to crappies. So
It's
they must
interesting, because
be
I would think of the crappies
oversusceptible.
being kind of a hardy fish, so that's interesting to hear that they had issues because of that. So just to refresh, your water quality, your biotic indices that you do the score for, we get poor 1 to 2, fair 2.1 to 2.5, and good up to 3.5, and I'm ignoring what you might see on your data sheets beyond that. So statewide, we've got over 4,000 samples. In Waukesha County, almost 700 samples collected. The means are almost identical between state and here. Fair water quality is the rating that we see. And then if you look at it by percent, we see about, in Waukesha County, about, say 1 out of every 5 samples is good, 1 out of every 5 is poor, and then you're looking at, just over half are fair water quality. Statewide, we actually have more good than we do in Waukesha County if we're comparing that way. And then to look specifically at what you all are seeing, and I'm gonna throw on the colors here. So we've got poor in red, our orange is fair, and then good up here. So we are seeing, again, this is your mean, this is the range for your site. So like, for instance, Bark at Genesee Lake, that's quite a range that is being observed at that site. But our mean is within that fair range. But what to me is curious is what's happening at certain times to cause such a range. And same with a couple of the other sites, Genesee, Bark at Sawyer. What's causing that range? One thing that came to mind, and I didn't check yet, this is where I wish I'd had more time, was what time of year are the samples being collected? So for instance, if you were to collect in a year when there was like an early hatch, and you go out in May and there's a lot of things already flying around as adults, and they're not necessarily findable in your sample, you might get a lower score at that time of year because you're not collecting them in your tray. Or there could be other factors that I haven't thought of. But just to me is curious is what's causing these big ranges and why is it not staying kind of closer in at each site?
Just the difference in detectability between spring and fall.
What is the difference? Or
No,
you're
no,
saying that's-
that'll be a big factor
Sure, we
because
could,
the
yeah,
critters are
separate
so
out.
much smaller in the fall that they're hard to detect.
Yeah, so
And
if you're
that-
going out
and-
early in the fall versus like in the end of October and you're missing
Yeah.
them happening, that's true. There's
Yeah,
there's a
there-
difference. The water quality score tends to be better in the spring sample than in the fall sample from the biologists who are doing the collection. So that's and I didn't even think to separate it out by spring and fall. I should have done that between the two. That's a good point. Everybody get a chance to see where your site lies? Putting in a plug for the Jane and the Scuppernong Creek site. So do there's Bark at Nixon,
Yeah,
Scuppernong Ice Age Trail. Is there
That's
a third
it,
one?
just the two.
So there's two sites in Waukesha County that we installed these nice signs. Jane and Karen and I last fall hammering them in. And the idea is that we wanted to share your good work with other people and try to let them know what's happening with the Water Action Volunteers Program, as well as educate folks about what is a watershed, what's non-point source pollution, and being able to see what it is that you all do. So if anybody has smartphones, this little code right there, you can scan with your smartphone and it will bring you to a website that's set up for using with mobile-friendly devices. And there are photos with just one sentence that says, volunteers in the WAVE program monitor temperature, and there's a picture of somebody doing it, and then they can go to the next parameter. So there's 8 parameters they can see. They can also see the results for any site that they would like to. So a plug for
Is that
visiting.
Scuppernong?
That's, yep.
Just across the way from Ottawa Lake Campground?
No, this is Scuppernong, that's Scuppernong River down there. This is Scuppernong Creek, so this is kind of between Wales and Dousman. Scuppernong Creek kind of meanders in through there.
And I'll say it's the first site where we got a random person to tell us that they were there and that they were interested in doing monitoring. So I don't know if that person's gonna get involved this year or not, but.
I never heard back from them.
Oh.
But
Okay, so for oxygen, again, everything needs oxygen to survive. Same thing with the biotic index connection to oxygen. We know that water at a certain temperature can hold a certain amount of oxygen. Colder water can hold more than warm water. When I teach, I usually use the analogy of a cold soda on the counter on a hot summer day versus, a soda on the counter for 4 hours on a hot summer day versus the fresh poured one, and you get the more bubbles coming out in the cold one. Same principle applies. More gas can dissolve in a cold liquid than in a warm one. So we want, if we were trout, we want colder streams to swim around in because we have more oxygen. Saturation. So Joe's talking about 140% saturated. So water, if it at a certain pressure and temperature can hold a certain amount of oxygen, when it has the amount that it's supposed to be able to hold at that pressure and temperature, it's called saturated. It can be supersaturated if there is more oxygen being made than is able to be diffused off or used by organisms than it's making. So if there's nutrient pollution and there's a lot of plants and they're hot, sunny summer day and they're making a lot of oxygen, it's probably going to be over 100% saturated at that point. So you probably, how many people have seen more than 100% saturation? A couple people. I usually say they're happiest with 80 to 120, and then we get the bulge eye. That's
You
bulge
start
eye
seeing
disease
that
or
at
something.
about 140.
140. And then it's going to change over 24 hours, right? You know, just before dawn is the lowest because everybody's been breathing at night, nobody's been making oxygen. So in nutrient polluted streams, you're going to get a wider range. You're going to get lower lows in the morning and higher highs in the afternoon of your oxygen because of the nutrient pollution or things that are affecting the oxygen that we do on the land. So just to give us context, so below 2 milligrams per liter, pretty much aquatic life doesn't like it. They need more than that. And again, milligrams per liter is equal to parts per million, so 2 parts per million. Below 4 or 5, some things are going to be okay. Some kinds of fish like carp and whatnot, even bass will be okay, but they're not going to be happy for a really long time. They would prefer it to be a little higher. When you get up to 6 and 7, trout are doing well. That's a state standard. We can't drop below that in designated trout waters. And then there's actually some specific classifications for water standards. I'll show you those. So these are by state standard classifications in Wisconsin. So trout waters have to be no less than 6 when it's not spawning season and no less than 7 when it is spawning season. If the waters are designated as fish or aquatic life, they can't drop below 5 milligrams per liter. If they're designated as limited forage fish waters, can't drop below 3, and if they're designated as limited aquatic life waters, they can't drop below 1. So that's pretty generous, right? We'll call it not much is living there. So what you can do is we can find out what your streams are classified as, and sometimes it's general and sometimes it might be a trout water, and then you can see, hey, my stream I should never see below whatever number at my site, and you can judge based on that.
Question.
Yeah.
All our streams, for the most part, are shallow. If you're in a deeper river, so to speak, does the oxygen like a lake? go
It can.
up and down ladder?
It can, but generally, we work under the assumption that streams and rivers are well mixed, which, because they're moving it into like a dammed system and impoundment, then it can start to look and act like a lake, for sure. And that's what happens in the lake is it changes top to bottom, depending on the time of the year, and it flips at times of the year as well. So linking our oxygen with plants and animals. If you have a lot of oxygen, again, your trout are happy. The sculpin that like to live in the streams with the trout are happy, and a lot of plant variety, which makes sense because they're making the oxygen. At the other end of the scale, your carp. Oh, who asked me about green sunfish? All right, they must be hardy. They're at the low oxygen level, so they're going to be able to survive at lower levels. Fathead minnows, they're in a lot of streams, and less plants.
I don't know what green sunfish are.
They look like bluegills, but they don't have the blue ear, so the green tinge, but they pretty much look like bluegills. So looking at our dissolved oxygen, I split it up for the pie charts by these 4 categories. The trout water is above 6, 5, 3, and 1 milligrams per liter. So most of our samples, both statewide and in Waukesha County, are good. What you all are seeing is good. Again, we're going to go to what's a possible weakness is, did people go out in the morning? If you went out in the afternoon to monitor oxygen, and you're telling me it's above 6, that might not mean much, because I want to know what happened, what's the worst conditions that these organisms are facing. So if you can go in the morning and you haven't been, that's the time to go. The thing about dissolved oxygen in terms of data use, your point-in-time dissolved oxygen data are most valuable that day. And if there's a problem, we would like you to tell people that there's a problem, because the biologists, I think there's 12 maybe biologists that work for DNR in the state, they can't be at all 84,000 miles of stream, which is where you all come in to help identify if there's an issue. And so in this case, we're only seeing, say, 0.15% that are, or 0.15%. See if I can do my colors. Fisher farlight, my colors are really bad because they're like the same. Apologies, I think that was an accident. In any case, really small percents of what you're observing of bad oxygen, but that's what we want to know. When you see it and if you see it, that's what would like to be reported. So let's look at your data from the sites that are here. So we're seeing, for the most part, again, the means here for above 6, everybody looks good. But there's a couple sites, here, and here, where maybe there was a phone call that could have happened to tell somebody, hey, I'm seeing something that could be a problem today. If we're below 4, that's when it starts to get to be a problem for the aquatic life. So my message there is, if you do get below 4, first repeat the test, whether you're using a meter or the hack kit. If it's still low, then please call. Either call Jane or we have a website, which it's cut off at the bottom down here, but on the Water Action Volunteers website, this is for Waukesha County, so these are your people that you would call. There's also a DNR tip line, 1-800-TIP-WDNR, where you can call and say, I have observed low oxygen. Volunteers have been the first to see when there's a problem and have identified fish kills that are coming, essentially, or have identified illegal discharges. And companies have been fined based on having that been figured out what was causing the low oxygen. Sound good? Okay, for habitat, how many people do soft habitat assessment forms versus rocky? Yeah, soft? Rock, how many people do rocky? I'll tell you in a second. You'll know what you do because I have it plotted. The big thing about habitat. Oh well, you don't because Jane.
Because I had done those. They're,
okay.
Yeah.
Yes, you don't even know. Okay, so here's the deal. Habitat is just looking at the stream bottom, the banks, and alongside the stream to see how good it is for aquatic life. The reason that we're changing our habitat assessment this year, in the past, it's always been volunteer-specific form. It's 10 questions that you answer. We're actually shifting over to use the same habitat form that the Department of Natural Resources biologists use. And as Jane said, we're trying to align the volunteer program better with what the department data needs are. So we say, okay, we're just gonna have the volunteers use the exact same form because that makes sense to our biologists and what kinds of answers you're getting. So that will change over time. So there's two kinds of forms, if you have a soft bottom or if you have a rocky bottom form. So in Waukesha County, slightly more soft bottom assessments than rocky bottom assessments. The range that you can get of habitat is 13 at the low end to 52 at the top end. So we've seen pretty much the whole range for the rocky habitat assessments, both statewide and in Waukesha County. For the soft habitat assessments, we haven't seen the lowest for our soft habitat assessment in either place. So here's the sites that were done for the rocky habitat assessment, looking pretty good. They're quite right up near 40. The test corners, that's yours.
Yeah.
Not looking so great.
Lot of erosion there.
Okay, there we go. A lot of erosion. And then if you look at the soft habitat, those ones actually look pretty good. Again, 52 is our top. So pretty much every site except for two, Pewaukee, Capitol, and Zion, are right up there looking good for the habitat assessment. Okay, so stream flow. This is one where Jane mentioned that we're looking to try to get more stream flows from the volunteers, and that's based on the fact that the Department of Natural Resources permit reviewers for high capacity wells or for irrigation wells, they often don't have data about places, and they only need data that are good to order of magnitude. Is it 1 cubic foot per second? Is it 10 cubic feet per second? Is it 100 cubic feet per second? Just to give them an idea to get started on their permit reviews. So they're looking to try to get more flow data so they can have information to inform their decisions. So this is one where the pie charts, well, they are what they are. So we know statewide, 7% of the sites are really tiny, and I'll show you a picture of what size these are. 8% in Waukesha County. We know almost 60% statewide are the biggies, over 10 cubic feet per second, and about half of Waukesha County are over 10 cubic feet per second. So what do those look like? Tiny, 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 0 to 1, like this deep, like this wide, really little. 1 to 10, the middle picture, and then greater than 10. The one that's there is about 125 cubic feet per second, just to give you an idea what it looks like. So what I know from Waukesha County is mostly folks are monitoring fairly small streams, which is good, actually, makes me feel safe, because you can wade in those pretty safely. None of them are outrageous. The Bark, I can tell, is a bigger stream. It's up by the 130 or so as a mean. So that's a bigger river. So for pH, for people who are doing the level 2, we know pH is acidic to basic, 1 to 14. It's a logarithmic scale. So if you go from 6 to 7, that's a 10 fold increase in the hydrogen ions. We know that in southern Wisconsin there's a lot of limestone, and so if there's something that's coming in as acid, whether it's rain or some other off the land source, we know that the limestone is actually going to not let the water's pH change very much as compared to northern Wisconsin, which is granite, and that's not going to have a buffering ability for pH. If there's something acidic coming in up there, it's going to change the pH of the water much more readily than down south. If the pH does change, metals as ions are going to be more freely available, and it's going to change the nutrient availability within a stream of certain kinds of nutrients. So we know that there's a state standard for pH. It's between 6 and 9, and basically we're just looking to see if people's pH lies within that range. Thinking about what it means biologically, I tried to make it so you could read it, so it's a little bit funny. So here's our tolerance range for fish. They're about between 4 and, I think it's the 9 line, or 10. 4 and 10 for fish. Wisconsin standard is 6 to 9. And then optimal fish are probably pretty happy, just above 7, just above neutral. But things, when you get down towards the acidic side, you're gonna see salmon eggs could start to die, bass and trout start to die, caddis and mayflies start to die in this 4 to 6 range. So we're not seeing those numbers really at all in Wisconsin, but if we did, that's what could happen biologically. So what you're seeing here for sites that do have the pH, I only put the state standard range here, and everybody lies within, you're in that happy range for the fish, in that just over neutral level. I was surprised though that there was a range. It's a little bit wider because again, if you're going one point is actually quite a jump in pH. So for instance, Battle Creek at BB, it's kind of a big range for what you're seeing for pH over time. For temperature. So again, temperature is related to organisms' survival or presence. Trout, for instance, want cold water because there's lots of oxygen. Temperature, if there's high temperatures, things are going to respire faster. Chemical processes are going to go more quickly. Plants and animals will react to temperature in that way. Temperature is also important in terms of climate change, what's happening over time. And I wanted to share with you that one way that your data, for folks who have done the level 2 with the thermistors, the data have been fed into this Northeast climate study, which is northeastern United States, that whole blue area on the map. And so they're looking at what's happening with climate change over time. And one of the things that we're trying to do this year, another change to the program, which is a little bit minor, is rather than just having the thermistors in from May to October, we want to leave them in year-round, and we're going to try to stagger it so that everybody gets to pull them and put them back in a nice warm month rather than sending you out in the freezing cold runoff in the spring or in the winter snow right before snowfall. So if you are somebody who does a thermistor in your game to do it year-round, that's something we're going to start to do, and it's based on feeding it into the climate change studies. The one risk we have is that there could be ice in the winter that's going to send them off to Illinois or wherever they might go, but we're going to take the chance to hopefully not lose too many. So thinking about what it means for the different organisms, and I've said it already, the trout, they like it cold. If you think about some of your insects, and this is research I looked again through the research, mayflies, stoneflies, and caddisflies, they're okay a little bit warmer. I apologize, it's all C, sorry. So 10 is 50 degrees Fahrenheit. 21 is 70 degrees Fahrenheit. 30 is called around, is it like 80 maybe? Yeah, give you that conversion. So our bass and sunfish and catfish and our mayflies and bass, sunfish, and catfish and darters, they like it warm. But some mayflies, the stoneflies, they're going to start to die when it gets up into that 70 to 80 degree Fahrenheit range. They like it more in the 50 to 70 range. One of the other things about temperature is there's stream classifications in Wisconsin. There are cold, cool, and warm water streams. So there's a definition in the state, and it tends to be that we use the one over here. Rather than instantaneous, we can use instantaneous for those who are doing instantaneous temperature, but when the DNR staff are doing actual classifications, they use your continuous data for temperature, and they look at what's called the maximum daily mean. So they say, okay, over all these days, how high, how warm did it get as an average? What's the maximum average that we saw at that site? And then they can decide if it's a cold water stream, it's going to stay less than 72 degrees Fahrenheit. If it's a cool water stream, it will be a little bit more than 72. And if it's a warm water stream, it's going to be more than 75 degrees Fahrenheit.
When you say trout died, how quick did they die?
I would
mean,
say
a few days?
Yeah, I mean, it's probably, the studies are probably done in a tank, so I don't know for sure what the answer is. In real life, the fish are going to try to swim away as much as they can to get out of that situation. and so they may not necessarily die, but they might leave. But in terms of death, I don't know the answer to that.
20,
Do you
20
know?
you get up to about 25 or 26, and if they've got no place to go, they're belly up pretty quickly. And that I've seen that, for instance, in the Mukwonago River, where seeing brook trout go in, even with acclimation, at about, oh boy, I think it was about 24, and they did not do very well. They just cannot, when the temperature gets that high, there's just not enough oxygen in the water to support them. And
So a couple days or what?
no, 15, 20 minutes.
Really?
Yeah, I mean, typically when you see fish kills because of low dissolved oxygen, they happen pretty quickly. And it's
Yeah, well, and one of the things like low dissolved oxygen too, like we were at a site a couple summers ago and we had oxygen levels of 0.17 milligrams per liter. So basically no oxygen in the system. So in that case, it's a little bit different than a warm water situation. It was a whatever, there was a chemical in the system, so there was just nothing there to breathe. So that makes sense where you would just go belly up if there's nothing. So it depends what is the level of the oxygen. If it's a temperature-based thing, it may not be as low as 0.17, but if there's a chemical and temperature connection that's making it that low, then it could be.
So what's the range of carp?
For their
Temperature.
For temperature, I don't know. Do you? I don't know. I'd have to.
Yeah, the only place I have ever seen carp stressed is there are some ponds. If you know what wing spread is down in Wind Point, it's at Johnson Foundation's headquarters. They have some ponds that were warm enough and low DO enough that the carp were actually coming to the surface and gasping for breath. It was.
Wow.
Yeah, those ponds are in pretty sad shape, but
Yeah, so
that's
I don't know
the
for
only.
sure. Yeah.
It's the only time I've ever seen carp stressed.
Yeah, yeah. So I don't know for sure for temperature. So what I did is I took the folks who have level 2 site data, and these are in your reports that I handed out, in the last page. What the reports do is they plot out your continuous temperature data over time. So the dates are hard to read because there's a lot of them, but for instance, this is for Bark River, Genesee. It started in May of 2006, so this is only, looks like it was just 2006 that they had a thermistor in. The orange line is our cool and warm water classification, so above this would be warm. This is our cold water, so below this is cold, and in here is so here's warm, here's cool, here's cold. That makes sense? Okay, and then the line that I think we want to look at is our green line, because that's our daily mean temperature. So the maximum daily mean temperature is what we want to know. If we ever see the green line go above the blue line, we know it's not a cold water stream. If we see the green line go above the orange line, we know it's not a cool water stream. So what do we have at the Bark River, Genesee? Do we have cool, cold, or warm? Where does our green line go above? Is it cold? Does it go above the blue? It does, right? So we know it's not cold water. Does it go above the orange? The green line? So right here, it's above the orange, right? So it's, and above here, yep, you're right, a couple times. So at least twice it goes above the orange, which means we're in a warm water system on the Bark River.
But that's July and August.
It is July and August, but in a trout stream, there's groundwater feeds, and so it will be 50 degrees Fahrenheit. It will stay cool no matter what time of year it is. So let's look at one other thing to keep an eye on that I thought was interesting. This one doesn't show it, but because it's only 2006, for some of the sites that have multiple years of data, we're going to look at what happens over the years and see what's happening with temperature, which I actually found very interesting over time.
Bark River should have multiple years.
It could be that's good. Remind me of that when I write it down. The report, some of the reports seem to be working right and some of them don't. So if it's not working right, I need to go back to the programmer and say, hey, it's not pulling the data, and I don't know why, but remind me, because I want to tell the programmer that. So this one, we've got Mason at Peterson, 2012, it's only 2012 in this case. So we see our blue cold water, our warm water line, and again, we just barely, in this case, get up in that warm water system with the green crossing. But then what's happening, so this is only 2012, it's getting colder as we get into the fall. So we start in June and we go to October, so that makes sense. We're getting colder in the fall. That makes sense? You see a generally decline. And you see the up and down, you're seeing daily, it gets colder at night and warmer in the afternoon. Okay, so we've got Bark River County Road P, lots of data, 2011 all the way to 2014. So this is one where it is pulling all of the information. We start in April and it ends in October over that way. So in this case, again, we're seeing green line, it's warm water, right? The green goes above the orange, so we're seeing warm water. And you see, remember 2012 was the drought year? A little bit warmer in 2012 than in 2013 and 14. Probably more water in the system than getting dried out. I remember Jane, we had to fix the database to allow it to enter crazy numbers. Cocoa Creek at Yent. So here's one where our green is mostly below the blue, right? Except right here and right here, and this is 2010. But in this case, we've got a cool water system according to the temperature that's being collected at the thermistor, because that green never goes above the orange. That makes sense? Oconomowoc West Shore. So this is one from 2012 to 2014. I think it's getting colder. Again, possibly because it was a drought system, or drought year here, when there was less water, easier to heat up if it was a shallower system. And here, it's clearly a warm water system. We got green above, and then 2014, it's still above, but it's not so above as it was in 2012. So, I think that the data that you all have collected, that the streams are looking, in general, they're looking pretty good. They're in that fair range. There's certainly some issues to watch for those dissolved oxygen sites. There's some of the biotic index samples look, 1 out of every 5 indicates poor water quality, and that's where I already said, is it a timing thing? Is it when we're going out to do the collection? I don't know, and I could dive more into the data and see if we can start to figure out what's happening with that, or if it's truly that the sites are showing that it's poor water quality. The temperature patterns over time, I'm going to take back what I said. I mean, it makes sense. Well, I won't take it back. 2012, I think, was that drought year, so we were seeing warmer temperatures to 2014. I tried to add in a slide, but it wouldn't load. I was going to show you what the data sheet looked like, but in any case, you don't need to see it. You'll see it later if you want to see it. So you've been asking questions as we go, but do you have other questions at this point?
Has the data shown that streams are warming through the years? I mean, like what Ricky says,
So the data that we have that I just looked at, I don't think if anything, it's looking like it's cooling, which is what I thought was a little surprising. But then I said, okay, well, it must be because of the drought year in 2012 where things were looking a lot warmer, and maybe that thermistor was closer to the surface or whatnot, or the stream was shallower. But we only have 3 years of data, and I didn't look at broader. So in the data set that you all have collected, no, it's not showing that. But 3 years, we'll have to see after 10 or 20.
You need a lot of data, and you need a long data record to detect those kinds of changes. This is very noisy data, and getting trends out of that noise is not easy anyway. To find that sort of trend into this sort of stream data, you need some very powerful statistical methods, and none of these sites have enough data to see that signal.
Long time periods, right? I mean,
and long time periods on that, and in general, our water quality data set in this part of the state only goes back to 1964. You know, 'cause
It's
that-
probably true most of the state, yeah.
Yeah, and that,
For
and,
most, yeah.
and that's only, and that's a long one, and that's mostly because of the sewer pack benchmark study that was done in 1964 and 65. So, you know, in most of these systems, we just don't have the data.
Well, and I would say statewide, there's, what the biologists are able to do is they don't monitor anywhere near 655 sites in a state in the year. They, long-term sites, there's some long-term trend studies where they do maybe 50 sites statewide, and they've been doing that since maybe
Yeah.
the 60s, maybe the
Yeah.
50s. So this is just like the volunteers being involved in collecting information is expanding the data set by so much. And you know, I want to be cautious. I don't want to tell you that your dissolved oxygen data are going in and being used for making management decisions for listing a water body as impaired, because point in time dissolved oxygen data, the reason they're important is if you tell us, hey, I think there's a problem today, and then somebody can go out and try to address it, versus if you're doing continuous temperature data, that could feed into a warm, cool, cold water classification over time, or climate change research in the future. So the different kinds of data are going to be used in different ways, but you are definitely building on a small data set from what the biologists are able to do on their own.
Some of these data sets are very small. I just worked up for the stream plan that we're doing for Mason Creek. I just worked up all the data a while back, and not just the wave data, I mean all of the available data, and I had fewer than 110 water quality samples in the whole watershed. That's small even by what I do. I did the Root River watershed, and going back to 64, I had 15,000 samples. And again, that's a small data set.
Chris, I have a question. You went back to calling you, or making a phone call immediately. And why is it so important to jump on a change?
To if you see a low dissolved oxygen?
Yeah.
So because there could be a fish kill. So if, I'll give you the example of where somebody was fined. There was a company with an illegal discharge, and it was causing low dissolved oxygen, which can cause a fish kill. So the idea is if somebody notices it soon, then something might be able to be done. Say it's a manure spill, maybe it can be stopped before it gets worse, and then put a barricade or stop the discharge, stop it from happening, and hopefully minimize the fish kill. So the idea is that at that level, there's going to be a fish kill, and let's see what we can do to minimize the impact of that by telling somebody who can then take action to figure out what the heck is going on. So that's why it's an emergency, if you will.
Can I take one question?
Sure.
Certain portions of the state, people's water table is really being poisoned because they have these cattle farms of 3,000 to 8,000 cows, which the state is okay. Yet if you talk to the local people, so how would you even measure that in the water table? That would all drain into the stream?
So you're like the manure.
They just have too much manure
runoff.
to get rid of.
So measuring it in a number of different ways. So you could measure bacteria levels in a stream, and if bacteria levels, there are standards for bacteria. If it's above the standard, then something needs to be done to address the source. And so if they can trace the source, which would likely be a cow, then they can do something about it. There could be other methods, so like phosphorus is one that could be linked back to agriculture. If there's phosphorus issues, which there are in many places in the state, then what's written is called a TMDL, a total maximum daily load, which is a report that basically says there's a pollutant, and this is the amount of the pollutant in this water body that makes it a pollutant, and we need to make a plan to clean it up so that whatever we're doing to cause that pollutant to be at that level is not happening any longer. So, for instance, in the lower Fox River Basin, they have a TMDL for phosphorus, total suspended solids. Phosphorus moves connected to sediment. So they currently are implementing their TMDL plan so that sometime in the future, I don't know if there's actually an end date when they're planning to have it clean, but theoretically, what is supposed to happen is they are supposed to do stuff on the land that makes it so that they no longer are polluting the stream with that phosphorus. Same thing would happen for bacteria the state is required every 2 years to submit to the EPA, the Federal Environmental Protection Agency, a list of impaired waters and by what means it's impaired. So they would say, okay, this water body is listed for bacteria, for temperature, for total suspended solids, for phosphorus, and when a TMDL is written, that's supposed to then spark action on. The catch is that these things are being written, these TMDLs are being written, and these implementation plans are happening, but it's very difficult to actually do stuff on the land that makes a big enough change that the pollutant goes away. So that's where I believe they call what we are dealing with in terms of water pollution issues wicked problems, because it's somebody's economy, whatever, let's say it's agriculture or industry that needs to make their profit to survive, and we want their product to survive as well. How do we balance their needs with the needs of the environment? It's a wicked problem. So theoretically, this system should work. We write a plan, we say this is what we need to do to fix the water quality problem, we implement it, the water quality problem is fixed. It's just not simple to actually make that plan happen. Does that make sense? Sure.
How could we get more efficiencies in this whole system? I see now that on Mason Creek, in 1 year's period of time, Jane took phosphorus samples. I was hauling water samples to the Conwalk sewer plant out of Mason Creek for phosphorus testing. And North Lake Management District hired this guru from UWM, I forgot his name.
Oh, they get samples for phosphorus?
Yeah, the samples for phosphorus.
Oh, that's a great question. You know, within the DNR, we try to push people to use the state lab of hygiene, which is what Jane did last year, because the state lab of hygiene, when they enter their results, they go right into the Department of Natural Resources database. So when the biologists are using the data to make listings of impaired waters, they feed right in. But these other labs, they're not necessarily fed right into the DNR system. So it's a disconnect, and that's an excellent question. How do we become more efficient and share resources? One would be we get more money so that all these labs that are certified in the state can feed their data into one place, and that the people who need the data to make decisions can get it out easily. And that requires a respect for the fact that data management takes time and staff and money to do it. So however we do that is another wicked problem, but I agree, and it would be, if we had endless money, if we were Bill Gates' money, what we could do with that.
One thing you can do is that when the DNR is putting together the impaired water list, which they do every 2 years, they do a general call for data on
That's true.
streams and sites.
That's
And
true.
if you have data, you can submit that.
That's true.
Those
We
data
just-
to the
call?
We
DNR.
just sent it out, I sent it out in December. There was a call in December I sent out,
Yes.
if you're on my spam list, the Wisconsin Stream Monitoring Listserv. If you got the newsletter the other day, that's the same list. I sent out that call. The one thing about it, it's doable, but it's a bit onerous to get it into the way that they need it. Having said it, I understand it, because if they're getting data from 8,000 sources, they need it all to be the same way that it's set up, so they can just put it all together. Otherwise, they could be forever trying to organize the data so that it aligns. But that's a great point.
Yeah.
But despite all that, I had no data. I was sending it here, they're sending it there.
But those labs
Somebody
have,
else
those
goes-
labs have the data, right? So where you're sending it, those labs can submit their data to the State Lab of Hygiene, and they can submit it
Yeah.
through this call, but they have to have, again, it's a money thing and a staffing thing, they have to have the staff and the time to be able to organize it, to get it to that centralized database. So, yeah, it's not an easy answer, but you're right, it would be wonderful to have better efficiencies and to share better.
Thank you very much.
Thank you all.